Welcome to my channel V Concepts CHM. This is the second part of the series Introduction to Lasers, where we will see about population inversion, pumping and active medium. If we consider an atomic system in thermal equilibrium, we see that the majority of the atoms are in the ground state compared to the atoms in the higher states. So if you incident a light of specific wavelength on such a atomic system, then the probability of the occurrence of absorptions is more compared to the occurrence of the process of stimulated emission, because there are more number of atoms in the ground state. So these atoms will absorb the incident radiation and go to the excited state, and this actually leads to the attenuation of light. Now some way, if we can make the number of atoms in the upper state more than that in the lower state, then an incident light of specific wavelength could induce large stimulated emissions, and this will not lead to the attenuation, but it will lead to the amplification of light. Einstein showed that both the stimulated absorption, that is the same process of absorption that we had seen in the earlier video, and the process of stimulated emission have the equal probability of occurrence under normal conditions. Of course, both the processes can be influenced from an external source, and it depends upon the relative number of atoms in the two states. So suppose N1 is the population of the atoms in the lower energy state E1, and N2 is the population of the atoms in the higher energy state E2. K is the Boltzmann constant and T is the temperature. We write down the Boltzmann distribution law, that is given as N2 by N1 is equal to exponential of minus E2 minus E1 upon KT. In this equation, if we take N2 as less than N1, that is the number of atoms in the lower energy state is more than that of the number of atoms in the excited state, then here the process of absorption will dominate. Spontaneous absorption will occur. Second case is we are considering N2 greater than N1. So the number of atoms in the higher state is more than that of the lower state. Then here the process of emission will dominate. So by some method, if we can increase the number of atoms in the higher state, that is N2 is made greater than N1, then stimulated emission can be achieved. Then we will actually achieve a state of population inversion. It is called as population inversion or inverted population. So this case is a state of population inversion. Number of atoms in the higher state is more than that in the lower state. So this situation where we achieve population inversion, this is the basic principle of laser. Now, so what we require is that there should be large number of atoms in the higher state. So these atoms we will get from the lower state, that is the lower state atoms are to be raised to the higher state. So for that we will have to supply energy to the atoms in the lower energy state. So this process is called as pumping. Okay, pumping is the process of raising the atoms from the lower energy state to the higher state by an external energy source, or it is also defined as the process of creating population inversion. There are different methods of pumping like optical pumping, electrical pumping, chemical pumping, inelastic atom to atom collision, or direct conversion. Like for optical pumping, light energy is used to excite the ground state atoms to the higher state. In electrical pumping, we use the electric field to excite the atoms from the lower state to the higher state, and so on. Now, the process or the method of optical pumping is what is normally preferred. Then we require an active medium. Active medium is the material that is used in a laser. It consists of a collection of atoms, molecules, ions. It can be the solid or a liquid or in the gaseous state, and they are capable of amplifying the light waves. So if a light beam of right frequency is incident to this atomic collection, there would be a large stimulated emissions rather than the absorptions. So this causes optical amplification. That is the amplification of light. So optical amplification can be achieved by bringing large number of collisions between the photons present and the active medium in their excited states. So in this figure, you can see the active medium, and on the two sides of the active medium, you can see two mirrors are placed, two mirrors M1 and M2, and this system of mirrors is the one which is used to obtain the optical feedback. This is the system which produces optical amplification, and this is called as mirror cavity resonator or optical resonator. The spontaneous emission from the atom is purely random, which I had mentioned in the earlier video, since the emission is occurring in all the directions. The emission along the directions which are not parallel to the resonator escapes from it. Okay, so some of the light escapes from here. Photons that propagates parallel to the axis of resonator will be tracing to and fro path between the mirrors because of multiple reflections. So that is shown here. The light or the photons, they pass through through the active medium. They will be reflected by this mirror M2. They will be again moving in this direction. Again, it will be reflected back from the mirror M1. Again, it will be reflected here from mirror M2. So the light will be suffering multiple reflections. So that way they will never be able to escape from the sides as they repeatedly pass through the medium. Some of them may collide with the excited active mediums. Thank you for watching this video.